Yes. What
We
did you
say that any number to power 0 is 1.
Okay. And we also
Then we
remind.
worked out some numbers basing on that rule.
All right. Jordan.
Yes.
Do you have anything to add apart from what Uday has said? On what?
No, only that. If you can give us another example similar to D.
Yes, Cynthia. Cynthia.
Yes, teacher.
Is there anything you want to add from the first session?
No.
Okay. All right. So without wasting time, let's move to another concept. In the first session, we are looking at zero index. Now let's look at what we call a positive indices. Are you seeing what is in the notes? Positive indices. Okay. Are you able to see what? Are you able to see the notes?
Yes.
Yes.
Yes. Positive indices. Let's look at positive indices. So when we talk of positive indices, a positive indices means we are dealing with numbers with a positive power. We are dealing with a positive. We are dealing with a positive what? Powers. Are you together? Members, we are dealing with positive what?
Powers.
Positive powers. So we are saying consider the product of numbers with an index. For example, we have a b squared. If you have like that, this one means this power is for a and b. Are you together? This power is also for a and what? A and b.
And B.
So which means we can write it as, we can simplify by saying the same as a squared b squared. Are you together?
Yes.
I remember the other time on Monday when we were looking at the law, there's something I mentioned where we are proving all these laws one by one. Recall where I said if I have a b to the power n, a b to the power what? N. This power is a common power. We call it a common power. So which means we are going to distribute the powers to all the numbers. So it becomes a to the power n, b to the power n. Are you together?
Yes.
So, and we are taking this power n is a positive, what? Is a positive power. Are you together? N is a positive
Yes.
power. We also went ahead and said, if I have a over b to the power n, this one, the law also permits us to write it in the form of a to the power n divided by b to the power n. Do you remember that?
Yes.
Yes. So that. So if you remember that, so that's basically what we mean a positive indices. That's what we call a positive what? Indices. Are you together, members?
Yes, teacher.
Yes. Let's go to those examples down there you're seeing. Let's look at those examples. Let's go to examples. If you look at, the question is simplify. Okay? Simplify. A, we have 2a to the power 3. You see, they are in brackets. They're in a bracket, which means this number is not the same. They are not the same as this. It's not the same as 2a to the power 3. Are you together, members?
Yes, teacher.
It's not the same as this. But the question is 2a to the power 3. It means now this power belongs to a. I mean to a and what?
2.
A and 2.
And 2.
Yes. So when is exams? When you are presenting your work in exams, okay? So you have to give me the method. You say, from, okay, you said from AB to the power n is equals to AB, then B to the power n. This one, you are laying foundation for your work. You are giving the method for your work. Are you together?
Yes.
Then after writing that, now you come and look at the question 2a to the power 3. So it means, what is our n? In this case, our n is what? Our n is it?
3.
3. What is our a? Our a is what? Our a is 2. Then our b
2.
is what? Our b is what? Our b is it?
A.
B is a. So when we substitute, now this one becomes 2 to the power 3 times a to the power what? 3. Have you seen that?
Yes.
Now, someone may ask, "But teacher, now we are multiplying. Can we multiply this using indices?" We cannot multiply this one using indices because they don't have the same. They don't have the same base.
Same base.
They don't have the same what? They don't have the same
Base.
So we are just going to multiply them normally. We are going to multiply them
Normally.
What is 2 to the power 3? You come and say, but
8.
2 to the power 3 is 8. Okay? So it implies
Yes.
now 2 to the power 3 times 8 to the power 3 becomes 8a2. Have you seen that?
Yes.
Yes. That was using the power law. The same also applies to B. Can we look at B? Can we look at question B? Question B, that's saying 3y squared to the power 4. 3y squared to the power 4. Who can guide me? What should I write? What should I write there? So it's going to, the power is for 3 and y, right? So it's going to be 3 to the power times y squared again to another power 4. Are you seeing that?
Y squared
to power 4.
So we shall have 3 to the power 4 times. We said when a number is raised to another power, what do we do to the powers? We multiply the what? The powers.
Y to
So this one,
powers
it becomes to the power 8. But what? Then you come and say, but 3 to the power 4 is 8 what? 3 to the power 4 is 81, right? Not so. So now it implies now
Yes.
3y squared to the power 4 becomes 81y to the power 8. As simple as
That.
that. Can you work out for me part C? I think part C you can work it out, right? Can you work out for me part C? All right. Have you finished part C? Have you finished part C? In part C, we have 2a to the power 5 times 3a to the power what? To the power 4. Okay? Members, are we together? Are we together?
Yes, teacher.
Yes. Now, when you look at part C, we have 2a to the power 5. This power is only for 5. It's not. I mean, it's only for a, not for 2. Are you together?
For A.
Then this power 4 here
Yes.
is only for what? It's only for a, not 3.
A.
Are you
For
together?
3, not for 3.
So means now what we are going to do, we are going to multiply
Yes.
2 and 3. We are going to multiply them normally. We are going to multiply them normally. So which means it's the same as saying 2a to the power 5 times 3a a to the power 4 is the same as 2 times a to the power 5, not so? Times 3 times a to the power 4. So we collect the like
Four.
terms. We collect the like terms. So 2 times 3 times a to the power 5 times a to the power 4. I think that we multiply this one normally. So when you multiply that one normally, you get 6 times. Now this one, when you look at this one they have the same what base. What do we do to the powers? We add the power. We add the power. So it becomes a 5 plus 4,
4.
which will give us 6 times a to the power 9. So when we combine them now, it will give us 6 a to the power 9.
9.
Have you seen that?
Yes.
Then number 2, question 2, example number 2. We have simplify. The question is simplify 24 a to the power 6 times 5 a to the power 3 divided by 8a to the power 7. Are we together? I think that?
Yes.
Yes.
What are we supposed to do there now? So we have 24 a to the power 6 times 5a to the power 3 divided by 8a to the power 7. So what are we going to do? Here we have 24, right? Here we have 5. So what do? We multiply them normally. We multiply this one normally. So it will be 24 times what? Times 5. Times a to the power 6 times a to the power 3 divided by 8a to the power 7.
7.
What is 24 plus 5? What do you get?
120.
120.
Huh?
120.
24 times 5. Some you are not sure. You get 120.
20.
Is 120. So 120, okay? Time. Here we have, I think this one, they have the same base. So what do we do to the powers? We add the powers. So it becomes
We
8
add them.
plus that. Okay?
The powers.
Then 8a to the power 7.
Yes.
So 120 times 8. So this one, when you add, you get 9, right? Divided by 8a to the power 7. So when you look at this, 120 and 8, we shall divide them normally. We shall divide them what? Normally.
Normally.
So which means we shall have is the same as saying 120 divided by 8. I think that, eh?
Yes.
Then a to the power 9. We are dividing this one now. We are dividing. What do we do to the powers? We subtract the powers, not so? 9 minus
7.
What is 120? 120 divided by
15.
8. We get 15. So 15. Then a to the power 9 minus 7. What do we get?
2.
2.
2.
That is our answer. I think that. Have you seen that?
Yes, John.
So when you are working out, what I'm interested here, which means here I will give you method 1. So method is very important. Okay? Okay?
Yes.
Then you also get bonus there. You also get a big bonus here. Then you get what? Accuracy 1.
Yes.
I think where you get marks from. So you don't, in mathematics, what is important is the steps. So don't leave out any steps in mathematics. Okay?
Yes.
Yes.
Yes. So are you seeing the question? Are you seeing the exercise there? The exercise.
Yes.
Let's pick
Yes.
any question from there and we do it. More examples. Let's go to more examples now. Someone just to pick us any question from there and we do it. Just pick any. Pick any from there.
15.
Which one?
15.
Number 15.
Number 15.
Okay. Question.
Oh, hello.
Question
Hello.
15. Can you write it down? Write it down. Simplify. We have. We have y to the power 3. Again, raised to the power 5.
5.
Have you seen that?
Yes.
Yes.
So what are we going to do? The question is just to simplify. Now, what we are going to do here, okay? We are going to say recall. What?
Recall.
If we recall, I remember somewhere we said if I have 1 out of A, 1 out of what?
A.
A is the same as A to the power negative
1.
Do you remember that? Do you remember that?
Yes.
So which means it implies now 1 out of 2 will be equal to 2 to the power negative.
-1.
Have you seen that? Huh?
Yes.
If that is true, so it implies now that I have y to the power 3 raised to the power 5. Now it will become 2 to the power 1 -1. I see that, eh? Y
Yes,
to the
teacher.
power y to the power 3, then what? 5. This bracket and this power 5 is for all of them. Is for all of what? Them. And we said if a number is raised to another power, what do we do to the powers? We multiply the what? The
We
powers.
multiply.
So now this one can now be the same as 2 to the power -1 to the power 5 times y to the power 3 also to the power what? To the power 5. Have you seen that?
Yes.
So when we multiply this one, what do we get? We shall get 2. -1 times 5 will give us negative
5.
-5.
-5.
Times y, 3 times 5 will give us
15.
15. Remember the question was? Remember, I think the question here. Leaving your answer in index what? In index form. So is there anything we do here? We leave it like that.
No.
We leave it like that. I think that. Members, we leave it like what?
Like
Like
that.
that.
The reason why we leave it like that because when you look at 2 and
That.
3, they don't have the same base. They don't have the same what? Base. If they had the same
And
base, we are going to simplify it further. Are you together?
yes.
So for this case, they don't have the same base. We shall leave it like that. There we have simplified. Okay?
Yes.
Which other question? That was question 15.
Somebody is raising up the hand.
Yes, who is that one?
No, it's a mistake.
Hello.
Was Sandra. Sandra? Yes, Sandra? It was a mistake, eh? Okay. Okay, which other question, members? Just select any of the one you see that we can do. We can discuss. Pick any. Which question?
18.
Question?
18.
Hello.
Someone is saying 18.
12.
Someone is saying question 18. Okay, let's first do question 18 and then we look at question 12. Okay?
Yes.
After that, any question now from there, you must be in position to do them. Question 18 is saying 2p2, okay? And the power is q is to the power 4, but it is again raised to the power 3.
3.
Just from when we recall very well, I said if I have ab to the power n, not so? This one will be a to the power n times b to the power n. Okay? You record that. So which means this power 3 here is for 2, is for p, and is for q.
Q.
So can we distribute the power? So distribute the powers, distribute the power. So when we distribute the power, what do we get? When we distribute the power, what do we get? We shall have, so 2p q to the power 4, the power 3. And this 4, are you seeing this 4? Is only for q. Okay?
Yes.
It's only for what? Q.
For Q.
So it becomes 2 to the power 3. Are you seeing that? Times
Yes.
p to the power 3
3.
times q to the power 4, also to the power what?
3.
So we shall have 2 to the power 3 times p to the power 3 times, what do we get here? This will be q to the power
12.
to the power 12. Have you seen that?
Yes.
So we leave our answer like that because the question here is very clear. Leaving the results in index form. Are you together?
Yes.
Yes.
So we leave our answer like that. But if they say just simplify, then we can go ahead and simplify because we know that 2 to the power 3 is 8. Then we write our answer.
Yes.
Or someone can say or, okay? Okay? So this one will be, it will be 8. Okay? It will be what? 8.
8.
8p cube, then q to the power 12. This is when we simplify further. But from the question, they were just saying we leave our answers in index form or in power form. Okay?
Yes.
Yes. So for this case, according to the question, we are going to leave our answer. We are going to take this one as the correct answer. Okay?
Yes.
Yes. Then someone also talk of question 12. Can you look at question 12? Let's look at question 12. Question 12. In question 12, what do we have? We have 4t to the power 7 times 3t squared
What did she write?
times t divided by t squared times 6t to the power 5. Yeah, look at question 12 members is here. This one. Okay? Okay?
Yes. Yes.
So we just apply the laws that we have already seen. We just apply the laws that we have already seen. So what shall we get now? What shall we have? We have 4. We have 3. Here we have 1. So 4 and 3, we shall multiply them normally. Are you together?
Yes.
Yes.
So it's the same as saying 4 times 3, then times what? There's a silent one there. So we put that one like that. Have you seen that?
Yes.
Time, then we open another bracket. So we shall remain with now t to the power 7 times t to the power 2 times t to the power 3. Have you seen that?
Teacher,
Yes?
where does the silent one come from?
There's a silent one here, this one.
Oh.
You have seen it?
Okay.
Here.
Yes.
There's a silent
Yes.
one. There's a silent one here. There. Then here there's also a silent one, right? Which means I'll have 1.
Teacher.
Yes? Yes, please.
Is it a must to put it there?
No, it's not a must. I'm just showing you so that you know what to do, what to multiply exactly, okay? Okay?
Okay.
Yes. So when we remove the number,
Yes.
which is 1 and 6, we remain now with it t squared times t to the power 5. I'm separating them like that so that it becomes easy to work it out, so that you are able to see it clearly, okay?
Yes.
Now when we come back here, 4 times 3 times 1, what do we get? We get what?
12.
We get 12 time. So can we simplify this? Can we simplify this? So they have the same base, which is t. Okay. We add the power, so it becomes 7 plus 2, then plus 3, right?
Plus 3.
Divide by this one will give us 6 into the base is the same t, so this one will give us 2 plus
5.
2 plus 5. When you go ahead, this one will give us 12. This one 12 t what? This plus this is it? 9. 9 plus
12.
to the power 12. 12 t to the power 12. Have you seen that?
Yes.
Then 6 t to the power
7.
to the power 7. So the numbers, this one we divide them normally. So by 6, 1. By 6,
2.
2. So we remain with 2 into t to the power 12. T to the power 12 divided by t to the power 7.
The power 7.
Now here they have the same, we have the same base and we are dividing. What do we do to the powers? We subtract
We subtract.
the power. So t to the power 12 minus 7.
7.
So what do we get? We get 2t to the power
5.
5.
5.
As simple as
4.
that. To the power 4.
4. 5.
To the power 5. That is not okay. That is not okay.
Oh.
Now. Not okay. Not okay. Members.
Yes.
Now we have from that question there we have done question. We have done question number 15. We have done question number 12, and we have done question number 18. Can you answer the rest? Work out the rest. I'm waiting for the answer. We are starting with number 1. Number 1. Exercise. Okay?
Teacher, should we do all?
Yes, do all of them apart from the one we have done. Apart from number 15, number 12, then number 18. Do the rest. Okay?
Teacher.
Yes.
Yes. I need to work before the end of the day. Okay?
Yes, teacher.
Should we reach next week when you have, tomorrow when you have not submitted the work, I will call you direct on phone. I will call you number direct. Okay?
Yes.
I want to see those ones. Even start doing the work now. We still have some minutes. Start doing the work now. Maya. I said start doing the work now. Start doing the work now.
All the numbers.
All. All right. So let's end there. Members?
Yes, teacher.